Whatever happened to predictability? The milkman, the paperboy, evening TV. Did I get delivered here? Somebody tell me, please. Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, life is waiting to carry you home. Everywhere you look.
What's up, Dr. Dan?
What's up, guys? Alright, so today we're going to do some things with physics, probably kinematics. So, an airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds. Until it finally lifts off the ground. Determine the distance before takeoff. So we have a few equations that we can use here.
Man, this physics class is too much. Oh wait, I'm a snack. Heck yeah, it's gonna be good. Here we go. What the rotten? Oh my gosh.
Plus 2a delta x.
Professor Dan.
So
Professor Dan.
we're going to plug in.
Hey, Professor Dan.
What?
Huh. Okay, Dr. Dan. Every day before physics, I have a pre-physics snack. Today I had a bunch of nice ripe apples, but something happened and now they're rotten. So can I go to the trash can and throw them out?
We don't have a trash can.
There's one off the balcony.
Fine, go throw it away.
I'm out too, man. Alright, man, I want to go downstairs and check out the view from there.
Dude, alright, man.
Dude, you totally whipped.
Dude, I'm sorry. I did my best, man.
Gosh, you suck.
But you can't do better. Yo, Dr. Dan, we're back.
Did you make it?
Heck no, I did it.
Are you kidding me?
Sorry, it's a hard shot. 3 stories up.
We can use physics.
What a loser.
Watch this, kids.
The first step to solving this problem is listing out what we know. Since we know that Johnny threw the apple from a balcony 30 meters up, the change in y will be negative 30 meters. Since we know that Johnny threw the apple horizontally, this means that there will be no initial velocity in the y direction, and that the acceleration will be simply the acceleration due to gravity, a value of negative 9.81 meters per second squared. Even with these values, we are still unable to solve for the initial velocity of the apple. However, we can use these values in the formula the change in y is equal to the initial velocity in the y direction plus 1/2 the acceleration in the y direction times time squared to find time, which will allow us to solve for the initial velocity of the apple in the x direction. Next, we plug the values into the equations and find that negative 30 meters is equal to 0 meters per second plus 1/2 negative 9.81 meters per second squared times t squared. We then get rid of the 0.0 meters per second value and multiply both sides of the equation by 2. This leaves us with negative 60 meters is equal to negative 9.81 meters per second squared times time squared. Next, we divide both sides of the equation by negative 9.81 meters per second squared and find that 6.12 seconds squared is equal to time squared. Upon taking the square root of both sides of the equation, we find that t is equal to 2.47 seconds. This means that from the time that Johnny threw the apple, it took 2.47 seconds for the apple to reach the trash can. Now that we have found time, let's relist what we know. The change in time was 2.47 seconds. The change in the x direction was 10 meters. The acceleration in the x direction was 0 meters per second squared. And the initial velocity is what we want to know. Using these values in the equation, the change in x is equal to the initial velocity in the x direction times time plus 1/2 acceleration in the x direction times time squared. We can find the initial velocity of the apple in the x direction. Plugging the values into the equation, we get 10 meters is equal to the initial velocity in the x direction times 2.47 seconds plus 1/2 times 0 times 2.47 squared. Because any value times 0 is 0, we can get rid of the 1/2 times 0 times 2.47 squared, and are left with 10 meters is equal to the initial velocity in the x direction times 2.47 seconds. Upon dividing by 2.47 seconds, we get that the initial velocity in the x direction is equal to 4.05 meters per second.
Now remember your physics with this next throw. Let's go.
You got it, Professor Dan.
See, kids, that's how fun physics really is.
Physics really is fun, Dr. Dan.
Yeah.
In conclusion, we learned that by knowing only the height of the building, acceleration due to gravity, and an initial y velocity of 0, since the apple was launched directly forward with no upward or downward initial velocity, we were able to solve for time using the equation change in y is equal to initial y velocity times time plus 1/2 acceleration in the y direction t squared. And therefore our desired unknown initial x velocity using the equation change in x is equal to initial x velocity times time plus 1/2 acceleration of the x direction times t squared. Had we been given different values, such as the horizontal displacement or final y velocity, we would have used any of the following formulas as found on our formula sheet. Given our small amount of known information, solving the problem of how to throw an apple into a trash can off the 3rd floor of Kennard was made possible.
Thanks, Dr. Dan.
No problem.